All right, new topic. Finding the minimum required sample size. Let me briefly show you where that comes from. Let's sort of pull back and look one more time at the three formulas that we're using for the margin of error. Right? They are, the margin of error is Z alpha over 2 sigma all over the square root of n when we're dealing with mu, in which case we know the standard deviation of the population. It's T alpha over 2 S, it's not very good S, is it? S all over the square root of n. S all over the square root of n when we're dealing with the population mean in the case in which we do not know the population standard deviation, and it's Z sigma all over 2 square root of P hat Q hat, square root of P hat Q hat divided again by the square root of n. So if you note all three of these formulas, square root of P hat Q hat all divided by the square root of n, this is when we're dealing with the population proportion. Every one of these formulas goes like 1 over the square root of n, right? 1 over square root of n, 1 over square root of n, 1 over the square root of n. So what does that mean? Well, in particular, it means as n gets larger, for everything else held fixed, as n gets larger, the standard of error gets smaller. And why is that? Right? Does that make sense? I would say it does, because as n gets larger, the sample becomes a better and better representative of the population, and therefore the errors that you're going to make, the deviations in the sample averages are going to be smaller and smaller, closer to the population averages, and that's exactly what's behind this here. So in particular, if when you're creating confidence intervals, you're interested in a particular type of error. You want to fix the error. You don't want to make too big an error. Given that, you can calculate a minimum n that your sample size must be above. As n gets larger, e gets smaller. Set e, you've set n. And you can find those quite easily by, in each case, solving each one of these three equations right here for n. All you have to do is move n to the other side, square everybody, and you get one equation here for the case where we're looking at the mean, which is Z alpha over 2 sigma all over E squared. Something very similar here for the case in which we're using the student T distribution, and something just a little bit different in this case, P hat Q hat all times the square of Z alpha over 2E. So there's the three formulas. There's where they come from. In each case, you have to insert the proper values here, calculate, and since n is a discrete number, it's a whole number really, you have to round up to the next number. So let's knock off these two problems very quickly. Here comes problem number 1. Problem 1 says, how many commuters must we randomly select to estimate the mean driving time of Chicago commuters? So the population here, all Chicago commuters. But we want to grab some sample, and we want to make sure that the size of that sample is large enough that the error that we're making in this case is within 12 minutes of the population mean. And we want to be 90% certain of that. And the population standard deviation is known to be 12 minutes. So sorry, I read that sort of inside out. But you have to pick around there and see, first of all, didn't say anything about proportions. It's talking about means. What type of means? Well, those are the three words you need to see. Population standard deviation is known to be 12. Yeah? If that's the case, you're up here working with this formula. And if you'd like to find n, then you've got to find me a Z alpha over 2, you've got to find me a sigma, and you've got to find me an E squared. So I'm going to let you handle most of the calculations here, because if we're going to use 90% by this time, maybe you remember that 90%, for 90% of Z alpha over 2 is 1.645, I believe. Alpha, we've been told is, not alpha, sorry, sigma, we've been told is 12 minutes. And then below, we've said, let's keep the sample mean to within 4 minutes. To within means plus or minus 4 minutes. That is the E that we want. Okay, if we work that out, I've done it before, put it somewhere where I could find it. And this will, you can sort of see this. This is 4 into 12 is 3. 3 times 1.6 is 4.8, and a little bit of change will probably be 4.9. 4.9 squared is just a little bit short of 25. When you round up, you'll get 25. Let's do the same thing for problem 2. Okay. Let me take my time a little bit more with the reading of problem 2. It says the National Health Organization warns that 30% of the middle school students nationwide have been drunk. Concerned, a local health agency randomly and anonymously surveys 110 of the 1,212 middle school students in its city. Only 21 of them report having been drunk. To keep the margin of error at least 5% and for a 95% confidence, how many middle students do we need to survey? So a lot of populations going on here. There's a national population from which there is a proportion, 30%. Again, there's no word here anywhere associated with the mean. There's actually no word associated with proportion, but there is a percentage there given. That probably, not in all cases, but it probably leads you to a proportion. So there's that national organization, then there's 1,212 middle schoolers in a city, and of those there's a sample. So what we're really doing here is we're trying to study that local group of 1,212 by taking a survey of 110. And of those 100, so we're dealing with proportions, so if we want to find a minimum N, we're down here, we need to know P hat, we need to know Q hat, we need to know Z alpha over 2, and we need to know E. So let's see in fact what we need. What is the P hat? The P hat is the sample proportion. What sample? 110 students. We're taking 110 students, 21 of them report having been drunk. P hat is equal to 21 all over 110. Q hat then immediately is the complement of this number, 89 all over 110. 21 plus 89 will be 110. And if I worked out the percentage here, that it'd be something like 17%. This would be something like 83% then. Z alpha over 2. Let's see, we said we're interested in 95%. 95% turns into 5% in the wings, 0.025 in each wing. And I'm going to just cheat and say I believe that's 1.96. Again, if you'll work that out, please do. And E is 5%. It's 0.5. So let's put those numbers in. N is greater than 21 over 110 times 89 all over 110 times the quantity 1.96 divided by 0.05. Square that, round up, and you'll get 242. Answer to problem 1 and answer to problem 2. All right. Again, it's a formula or a set of formulas that either you just want to derive or you want to darn well quickly figure out where you can find those formulas. Perhaps on a formula sheet that I allow you when you're taking tests. Maybe you want to make that sheet up for yourself right now. All right, let's move on to the next subject.